Good morning, all of you. Welcome to Sri Jayendra Rank Zone. In the previous lecture, we have completed chemical equilibrium. Now we are going to discuss new chapter, that is ionic equilibrium. This chapter is also very important for entrance examinations. So please listen carefully all the topics and take out your classwork and start writing whatever the slides you have seen. And then you work out the questions 100% easily. You can get the answers. Now coming to ionic equilibrium, we are going to discuss ionic equilibrium today, lecture 1. Yes, this is ionic equilibrium. So what is the difference between chemical equilibrium and ionic equilibrium we are going to discuss now. So chemical equilibrium means the equilibrium existing between the reactants and the products in a chemical reaction is called as chemical equilibrium. Whereas ionic equilibrium is nothing but the equilibrium existing between the ions in aqueous solutions are nothing but ionic equilibrium. So let us see what is ionic equilibrium right now. This type of equilibrium involving ions in all aqueous solution. Here important point is ions in aqueous solutions is called ionic equilibrium. In weak electrolytes, equilibrium existing between ions and the unionized molecule. Here the important point is what is a weak electrolyte. What is a weak electrolyte? We are going to discuss now. So what are which type of compounds will come under this weak electrolytes? Acids, bases, and salts. Acids, bases, and salts come under the category of electrolytes and may act either as strong or weak electrolytes. So acid, base, and salts will come under into this category of electrolytes and may act as either strong or weak electrolytes. Let us see now the important discussion about ionic equilibrium. So before going to ionic equilibrium, generally in chemistry, all the substances are classified into two categories, that is non-electrolytic substances and electrolytic substances. What are non-electrolytic substances and what are electrolytic substances? So in chemistry, all the substances are classified into, all the substances can be classified into two categories mainly. So what are those two categories? That is first one, non-electrolytic substances, and second one is electrolytic substances. So what are non-electrolytes and what are electrolytes? Now we are going to discuss. It is very important to know this. So the substances which does not dissociate into ions on dissolving in solvent like water solution will not conduct electricity, and these are called as non-electrolytes. So the substances which do not dissociate into ions on dissolving in solvent like water or any other solution, it is, and they will not conduct electricity also. So these are called as non-electrolytes. And example for non-electrolytes, all inorganic compounds such as benzene, diethyl ether, some organic compounds, some inorganic compounds which are not. Usually already we know covalent compounds do not dissociate in water, whereas ionic compounds dissociate into water. So they dissociate into water into ions. So for example, NaCl when you dissolve in water, it forms Na plus and Cl minus. Na plus and Cl minus. So this is an electrolyte. And non-electrolytes means like carbon dioxide, benzene, diethyl ether. So this benzene, if you dissolve in water, first of all, it will not dissolve and does not dissociate at all. It will not dissociate at all. So that's why these are called as non-electrolytes. As they are not forming ions, they do not conduct electricity. As these are forming ions, they conduct electricity. So this is called non-electrolytes. Non-electrolytes are the substances which does not dissociate in water, which does not dissociate into ions on dissolving in solvent like water, and solution will not, the solution of these non-electrolytes will not conduct electricity. The solution of the non-electrolytes will not conduct, non-electrolytes will not conduct electricity. So this is called a non-electrolyte. Let us see now what is an electrolyte. Electrolytes are the substances which dissociate on dissolving in water into ions. These solutions will conduct electricity. All acids, bases, and salts. Acids, bases, and salts are called as electrolytes. Example, HCl is an acid. H2SO4 is an acid. Sodium hydroxide is a base. Potassium hydroxide is a base. Ammonia is a base. So all these are called as bases, and these two are called acids. We have many acids. Acetic acid is an acid, acetic acid. And what are the salts? HCl plus NaOH forms NaCl. NaCl is a salt. So all acids, bases, and salts are called as electrolytes. What are electrolytes? Electrolytes will dissociate on dissolving in water into ions, and the solutions of the electrolytes will conduct electricity. The solutions of the electrolytes will conduct electricity. So these are called electrolytes. Now, electrolytes and non-electrolytes definition we have completed. So let us see now what is the next concept we have. So electrolytic substances are further classified into strong electrolyte and weak electrolyte. Very, very important here. So why you are discussing? Because what is ionic equilibrium, you should know for this thing. What is strong electrolyte and what is weak electrolyte? The electrolyte when dissolved in water, the electrolyte which when dissolved in water completely dissociates into ions, completely dissociate. So completely dissociate into ions, they are called as strong electrolytes. Completely dissociates into ions. So these are called as strong electrolytes. Completely dissociate into ions are called strong electrolytes. Examples: strong acids, strong bases, and salts obtained by the means of strong acid and salt base. Salts obtained and salts of strong acid and strong base. This SCA is called strong acid, SB is called strong base. Salts of strong acid and strong base, they are considered as strong electrolytes. So the electrolytes which when dissociate in water, which when dissolved in water, completely dissociate into ions. Again, I'm repeating the definition. The electrolytes which when dissolved in water, completely dissociate into ions, 100% dissociation, are called as strong electrolytes, are called as strong electrolytes. Example, strong acids, strong bases, and salts of strong acid and strong base. These are all called strong electrolytes. Now, what are weak electrolytes? The substances which do not completely dissociate into water on dissolving in water, which do not completely dissociate into ions. They have partial dissociation. Weak electrolytes, we have partial dissociation. Partial dissociation. They are called as weak electrolytes. So let us see now examples: weak acid, weak bases, and salts obtained by the means of weak acid and weak base, or strong acid or weak base, etc. All these are called as weak electrolytes. So what are weak electrolytes? The electrolytes which when dissolved in water are partially dissociated into ions, which when dissolved in water, partially dissociate into ions, are called as weak electrolytes. Weak electrolytes. So as I told you, degree of dissociation for strong electrolytes, it is alpha is equal to unity, that is 100% ionization, that is equal to 1. So for strong electrolytes, alpha value is always equal to 1. And examples for strong electrolytes, as I told you, strong acids like HClO4, hydrogen iodide, hydrogen bromide, hydrogen chloride, H2SO4, HNO3, HCl, and strong bases: sodium hydroxide, potassium hydroxide, rubidium hydroxide, cesium hydroxide, barium hydroxide. That is alkali and alkaline metal hydroxides, alkali and metal hydroxides, and all types of soluble salts. That is strong acid, strong base, strong acid, weak base, weak acid, strong base, or weak acid, weak base. So these are all called as electrolytes. And here weak acid, strong base, or weak acid, weak base. Weak acid, weak base are called as weak electrolytes. These are called as what? They are not coming into strong electrolytes. They are called as weak electrolytes because they do not dissociate into ions completely. They dissociate into ions only partially. So these are called weak electrolytes. Continuation now. The weak electrolytes. In weak electrolytes, the degree of dissociation alpha is always less than 1. So they are not 100% dissociated. They are only partially dissociated. Partial here the word partially is important. They dissociate partially dissociated into ions. Those are called as weak electrolytes. Partially dissociated into ions are called as weak electrolytes. Example, weak acid like acetic acid, hydrocyanide, weak bases like ammonia, zinc hydroxide, etc. All these are called as weak acids. And sparingly soluble salts like silver chloride, barium sulfate, etc. are also called as weak electrolytes. And also salts obtained by means of weak acid and weak base. So for example, sodium CH3CONH4. This is called what? Ammonium acetate. Ammonium acetate is weak acid and a weak base. Since the combination is formed by weak acid and weak base, this is also called a weak electrolyte. So weak acid, weak base, ammonium acetate, because it is formed by the means of acetic acid treated with ammonia. When acetic acid is combined with ammonia, it will form so ammonium acetate. The name of this compound is called as ammonium acetate, which is a weak electrolyte, and it will not completely dissolve in water. It will partially dissociated into ions. So it is called ammonium acetate. So all these things are very important. Strong acid, strong base, weak acid, weak base. So weak acid, weak base are called as weak electrolytes. Strong acid, strong base are called as strong electrolytes. Salts obtained by the means of strong acid, weak acid, strong base, and strong acid, strong base. They are also called as strong electrolytes. And the salt obtained by the means of weak acid and weak base and certain sparingly soluble salts like barium sulfate, silver chloride, etc are all called as weak electrolytes. So these are all called as weak electrolytes. And important point in weak electrolytes is the degree of dissociation is alpha is always less than 1. It is just always it is less than 1. And in case of strong electrolytes, the degree of dissociation is always equal to 1. It is 100% ionized, and this is only partially ionized. So that's why all weak electrolytes, here I'm writing the sentence, please note it down in your classwork. All weak electrolytes are partially ionized in aqueous solution, are partially ionized in aqueous solution or in water. This is very, very important point. All weak electrolytes are partially ionized in aqueous solutions. These are called as weak electrolytes. So example for weak electrolytes is weak acid, weak bases, salts obtained by the means of weak acid and weak base, and certain sparingly soluble. So sparingly means only partially. Sparingly soluble salts like silver chloride, barium sulfate, etc. All these are coming under weak electrolytes. Weak electrolytes. So in this chapter, we are going to deal with weak electrolytes only mainly. That's why you should know complete thorough knowledge of what are weak electrolytes. What are weak electrolytes? The electrolytes which do not dissociate into ions completely or which dissociate into ions partially in aqueous solutions are called as weak electrolytes. Again, I'm repeating the definition. Please note it down. The electrolytes which are partially ionized in aqueous solutions are called as weak electrolytes. The degree of dissociation for weak electrolytes is always less than 1. It should be in between 0 to 1, not even 1 also. It is 0 to less than 1. And what are the examples of weak electrolytes? Weak acids, weak bases, salts obtained by the means of combination of weak acid and weak base. So this salt, this is ammonium acetate salt, is obtained by the combination of acetic acid and ammonia. When acetic acid is treated with ammonia, it forms ammonium acetate. It forms what? Ammonium acetate. And this is called a weak acid and weak base combination. Hence, it is called as weak salt. So it is salt obtained by the means of by the combination of weak acid and weak base. And apart from this, certain sparingly soluble salts like silver chloride, barium sulfate, etc., also ionized partially in water. So that's why they are also called as weak electrolytes. And last but not the least, all weak electrolytes are partially ionized in aqueous solution, and their degree of dissociation is always less than 1. So please note down in your classwork these points. Next, we are going to discuss, because in this chapter, weak electrolytes are only important because they only have equilibrium. They only attains equilibrium when they have taken in ions. Let us see how it happens. Now, before going to this Arrhenius concept, let us discuss now what are Arrhenius concepts of acid, base, and salts. So, next concept in this Arrhenius, and before this, I want to discuss one more important point. Since here, you please note down after this, I'll of this and Arrhenius concept will come. Since weak electrolytes since note down, please note down your classwork. This point is very, very important. Since weak electrolytes are ionized partially in aqueous solutions, there exists an equilibrium between the weak electrolyte, between the weak electrolyte between the weak electrolyte and its ions, which is commonly called as which is commonly called as ionic equilibrium. Example, when you take acetic acid, weak acid or weak base in a solution in water, acetic acid dissociates to form acetate ion and H plus ion. So this is called even weak base. If we take, when you dissociate ammonia into water, ammonia and in water, it forms ammonium ions and OH minus ion. So there exists an equilibrium between these three. So this is called ionic equilibrium. Very, very important. Since weak electrolytes are ionized partially in aqueous solutions, there exists an equilibrium between the weak electrolyte and its ions, which is commonly called as ionic equilibrium. So there exists an equilibrium. That's why we have given forward arrow and backward arrow. Whenever we are saying about equilibrium, we write like this. As you already know, in chemical equilibrium, we have done it. So this is commonly called as ionic equilibrium. So ionic equilibrium will be existing for weak electrolytes only. So by this, what you can understand, weak electrolytes exhibits ionic equilibrium. So please note down this sentence. Very, very important for understanding. That's why I have written like this. Since weak electrolytes are ionized partially in aqueous solutions, there exists an equilibrium between the weak electrolytes and its ions, which is commonly called as ionic equilibrium. So example, acetic acid is a weak acid, we already know. Since acetic acid, when you dissolve in water, it forms acetate ions along with H plus ions. Whereas ammonia, when you dissolve in water, it forms ammonium ions and OH minus ions. And after formation of ions, after some time, you'll notice that there exists an equilibrium. That is the conversion of the rate of conversion of acetic acid into acetate ions and H plus ions is equal to the rate of conversion of acetate ions and H plus ions to acetic acid again. So backward reaction and forward reaction. So as the rate of forward reaction is equal to rate of backward reaction, we can say they are in equilibrium with each other. So a weak electrolyte and its ions are in equilibrium with each other. So this statement is very, very important. Please note down. Please note down in your classwork. Since weak electrolytes are ionized partially in aqueous solutions, there exists an equilibrium between the weak electrolyte and its ions, which is commonly called as ionic equilibrium. Strong electrolytes do dissociate 100% dissociation. As strong electrolytes dissociate completely in water, we cannot say there exists an equilibrium between them, because strong electrolytes, if you want to show for strong electrolytes, let us see now. For strong electrolytes, what happens? For example, if you take NaCl, it is only one-side reaction, Na plus and Cl minus in aqueous solutions. They do conduct electricity. That's why they are called as electrolytes, and they are strong electrolytes. And there is no equilibrium between ions. So that's why this will not come under ionic equilibrium. Ionic equilibrium will come under only in for weak electrolytes. That's why I told you weak electrolytes are important, because as they are ionizing partially in aqueous solutions, there exists an equilibrium between the weak electrolyte and its ions. So this is called ionic equilibrium. So next concept in this chapter is Arrhenius bases and salts. Now we are going to discuss what are, according to Arrhenius concepts, acid, base, and salts. From here now we are going to discuss theory of acid, base, and salts. This is commonly called as theory of acid, base, and salts. So please completely all of you write down in your classwork this statement so that you can understand better what is ionic equilibrium. So ionic equilibrium definition is this only. So I'm writing it now. So I'm clearing the drawings. Now we are going to discuss theories of acid, base, and salts. So first theory was proposed by Arrhenius, acid, base, and salts. So first concept is Arrhenius concept. According to Arrhenius theory, an acid is a substance which gives H plus ions. An acid is a substance which gives H plus ions on dissolving in water. H plus is donor. Example, nitric acid, perchloric acid, hydrochloric acid, hydrogen iodide, hydrogen bromide, sulfuric acid, phosphoric acid, etc. All these are coming under acid groups. So what is an acid according to Arrhenius theory? An acid is a substance which gives only H plus ion on dissolving in water. So acid is a substance which gives H plus ions. And a base is a substance which gives OH minus ions. So types of acid we'll discuss now. After that, we'll go for bases. So we have three types of acids. Monobasic acid. If an acid is dissolved in water, if it gives only one H plus ions, we will call it as monobasic acid per molecule. So it is equal nothing but examples: HNO3, HClO4, HCl. And water dibasic acid, when an acid is dissolved in water, if it gives 2 H plus ions per molecule, we'll say it is called dibasic acid. So example, sulfuric acid, phosphorus acid. Even though this phosphorus acid contains 3 H plus ions, but still it is consisting as dibasic, because in aqueous solution, it gives only 2 H plus ions. So this is called phosphorus acid. Next, we have tribasic acid, which gives 3 H plus ions per molecule. Example, H3A and H3PO4. H3O actually it should be H3O plus ions, and phosphoric acid, that is H3PO4. So these are all the examples of acids. We have three types of acids: monobasic acid, dibasic acid, and tribasic acid. More what are monobasic acids? A monobasic acid is the acid which dissolves when dissolved in aqueous solution yields only one H plus ions. Which when dissolved in aqueous solution yields only one H plus ion. They are called as monobasic. Dibasic means which when dissolved in water yields 2 H plus ions. Example, sulfuric acid and phosphorus acid. And this is phosphoric acid. So this is called types of acids. So according to Arrhenius concept, what is an acid? An acid is a substance which gives H plus ions on dissolving in water only. Continuation now. If H plus ion in water is extremely hydrated, that is in form of H3O plus H5O2 plus H3O3 plus and high charge density, and HClO4 plus water gives us to H3O plus and ClO4 minus. This is called better representation. So H plus ions in water is extremely hydrated in the form of like this. Next continuation. What is Arrhenius base? According to Arrhenius theory, what is a base? Any substance which releases OH minus ion, hydroxyl ions in water are said to be bases. So we have monoacidic base, which gives only one OH minus ions per molecule when dissolved in water. Like example, cesium hydroxide, rubidium hydroxide, sodium hydroxide, ammonium hydroxide, potassium hydroxide, etc. And diacidic bases gives 2OH minus ions per molecule, like barium hydroxide, calcium hydroxide, and triacidic bases, monoacidic base, diacidic base, and triacidic base gives 3 OH minus ions per molecule. Example, ferric hydroxide. So OH minus ions is also in hydrated form of H3O2 minus, H7O4 minus, H5O3 minus. So first group elements except lithium form strong bases. First group elements except lithium ions, strongs, uh, Ionous base, any substance which releases OH minus ions in water are said to be ionous bases. So we'll discuss now continuation of this ionic equilibrium. So this is about ionous base. Any substance which releases OH minus ion, hydroxyl ion concentration in water are said to be ionous bases. There are three types of bases, ionous bases. Monoacidic base, which gives only one OH minus ion. Diacidic base gives 2 OH minus ions per molecule. Triacidic base gives 3 OH minus ions per molecule. Continuation now. Next concept we have Bronsted-Lowry concept. This is the first theory of Arrhenius theory of acid bases. Let us see now. Now, before going to Bronsted-Lowry concept, I will discuss limitations of Arrhenius theory. Why Arrhenius theory is failed? That is not given in the slides. So please note down limitations of Arrhenius theory. So what are the limitations of Arrhenius theory? There are many substances. There are many substances, many acids and bases which on dissolving in water, which on dissolving in water does not yield H plus ions and OH minus ions. H plus ions and OH minus ions. H plus ions and OH minus ions. Example, carbon dioxide is an acid but not yield H plus ions in acid. Next continuation. Metallic oxides like magnesium oxide is base which does not yield OH minus ions in water, which does not yield. Here in acid, we cannot say it is in water. Does not yield OH minus ions. So like that, there are so many substances which are considered as acids and bases, which are dissolved in water, does not yield H plus ions and OH minus ions. So that's why this theory is failed. That this is the only limitation of Arrhenius theory. Why Arrhenius theory is failed? Because there are many substances which are called as acids and bases in chemicals or in chemistry, which on dissolving in water does not yield H plus ions or OH minus ions. And example for this is carbon dioxide is acid, but not yield H plus ions in water, whereas magnesium oxide is a base which does not yield OH minus in water, OH minus ions in water. So that's why Arrhenius theory is failed. Now let us see second theory, that is Bronsted-Lowry concept, also called as conjugate acid-base theory. This is very important, and so please note down these limitations of Arrhenius theory in your classwork. I am giving time also for you to note down. So there are many acids and bases which on dissolving in water does not yield H plus ions or OH minus ions. Example, carbon dioxide is acid but not yield H plus ions in water. Magnesium oxide is a base which does not yield OH minus ions. And according to Arrhenius theory, an acid is substance which always yield H plus ions in water, and a base is substance which always yield OH minus ions in water. So that's why this theory is ruled out. So this is the main limitations of Arrhenius theory. I hope you have copied in your classwork. So let us proceed to next second theory of acid and bases and salts, that is Bronsted-Lowry concept. So next we are going to discuss Bronsted-Lowry concept. Here the spelling is mistake here. This is just Bronsted-Lowry concept only. It is not Lowry. It is only Bronsted-Lowry concept. It is also called as conjugate acid-base concept. Very, very important. From this theory, definitely you'll get a question for entrance exam. So what is conjugate acid-base theory? That also we'll discuss. So Bronsted-Lowry concept, also called as conjugate acid-base theory. Why it is called as conjugate acid-base theory? Also Protonic concept. Now we are going to discuss. Let us start now. So according to Bronsted-Lowry concept, substances which donate H plus ions are called Bronsted-Lowry acids, H plus donor, and substances which accept H plus ions are called as Bronsted-Lowry bases. So H plus ion is a donor and H plus acceptor. H plus donor is called acid and H plus acceptor is called base. Very simple. So to get Bronsted acid, add H plus, and to get Bronsted base, subtract H plus. So H plus acceptor and H plus donor in simple words. Substances which donate H plus ions are called as Bronsted-Lowry acids, and substances which accept H plus ions are called as Bronsted-Lowry bases. Bronsted-Lowry bases. So, according to Bronsted-Lowry concept, acid is nothing but H plus donor and base is nothing but H plus acceptor. Very simple language we are given for your understanding. So, please try to understand. It's very easy. Let us see now more about this theory. So conjugate acid-base pairs. What are conjugate acid-base? In a typical acid-base reaction, we can say HX is an acid and B is a base, for example. So acid, when combines with base, it forms HB plus. HB plus means base is gaining H plus ions from acid. That's why H plus X is acid. And B is losing, so, and here hex minus it is forming, that is called conjugate base. So conjugate acid and conjugate base. Forward reaction here, HX being a proton donor is an acid and B being a proton acceptor is a base. Simple it is. HX is a acid and B is a base. Since HX is donating protons, that's why it is forming HB plus. Since B is accepting proton, it is called conjugate base, and HX is donating proton, it's called acid. So acid and base. Now it is clear. Now with the acid, when acid combines with base, it forms conjugate acid. The conjugate acid is HP plus and conjugate base. This is called conjugate base. Why it is called conjugate acid, conjugate base? We'll discuss now. So please listen carefully. One more simple example I'll give you. For example, let us discuss now HCl when dissociates in water, when combines with water, what happens? It forms HCl when dissociating in water. So when HCl is dissociating in water, it forms H3O plus Cl minus. So here HCl is donating its proton to water. That's why it is becoming HCl, H3O plus. So HCl is an acid, and since water is accepting proton from HCl, so water is a base here. Water is a base, and when these two combines, it forms H3O plus. This is called conjugate acid. Conjugate acid, because what is the conjugate acid of HCl? Water, it is nothing but H3O plus. It is called conjugate acid. And what is the conjugate base of HCl? It is called Cl minus. So this is called conjugate base. Conjugate base. Why it is called as conjugate acid and conjugate base? Simple, I'll tell you. To get conjugate acid for a given substance, to get this statement is very, very important. Definitely they'll ask in the entrance exam. To get conjugate acid for a given substance, for a given substance, add H place, very, very important. And for conjugate base, subtract H place. Simple, that's all. Subtract H plus. So nowadays the conjugate base of HCl acid conjugate base is Cl minus. What is the conjugate acid of water, the water base? H3O plus. Because for water, if you add H plus, it forms H3O plus. And for acid, if you subtract H plus, it forms conjugate base. So to get conjugate acid for a given substance, add H plus, and for conjugate base, subtract H plus. That's all. Simple it is. So that's why here we can say in this Hb plus is conjugate acid and X minus is conjugate base. So for this acid, what is its conjugate base? Subtract H minus, H plus if you subtract, it becomes X minus. And for this base, what is the conjugate acid? For base, we have conjugate acid, and for acid, we have conjugate base. Simple word. For acid, you have a conjugate base, and for base, we have a conjugate acid. So what is the conjugate acid of base here for B, Hb plus, because for B what we have added H plus ions. So that's why it become, as we are adding H plus ions, it is called conjugate acid. As we have subtracted H plus ions, we got conjugate base. So to get conjugate acid for a given substance, add H plus, and for given conjugate base for a given substance, subtract H plus. So it is as simple as such that. So in the examination, entrance examination, they'll give one substance, the conjugate acid of above substance is, the conjugate base of above substance is, they'll ask. So to get conjugate acid for that substance, simply add H plus ion. And to get conjugate base for that substance, simply add OH minus, sorry, simply subtract H plus ion, subtract H plus ions and add H plus. That's why it is also called as proton theory. So it is proton donor or proton acceptor. So this statement is very, very important. So please note down in your classwork. Consider HCl in words I have given, that's why. So consider HCl plus water gives H3O plus ions plus Cl minus. As it is forming H3O plus ions, it is called conjugate acid, which should be there. And for base only, we have conjugate acid, and for acid, we have conjugate base. That's why it is called as conjugate acid base theory. So base conjugate acid is called conjugate base, and acid conjugate base is called also called as conjugate pair. So this is called conjugate pair. Conjugate pair. It is here shown clearly. So please note down. This is very, very important. Definitely they are going to ask in the entrance examinations like NEET, JEE means, etc. So for all competitive exams, entrance examination, this concept is very important. What is the conjugate base of the substance? What is the conjugate acid of the given substance? To get conjugate acid, add H plus, and to get conjugate base, subtract H plus for the given substance. That's all. So please note it down in your classwork. Let us continue now. Backward reaction. What is backward reaction? So here Hb plus being a proton donor is an acid, and X minus being a proton acceptor is a base, because Hb plus is a proton donor and X minus is proton acceptor. Because it can to become neutral, it has to accept H plus ion, and to become neutral, it has to lose H plus ion. Since it is losing H plus ion, suppose if we want to become B again, so what it has to do? It has to lose H plus ion. So this Hb plus should lose H plus ion. lose H plus ion so that it becomes proton donor and is an acid. And X minus it has to become HX means what? It has to be accept H plus ion, accept H plus ion. That's why it is called being a proton acceptor is called base. So example you can see here HCl plus water gives H to H3O plus and Cl minus. Here HCl is an acid because it is donating H plus ion to base, that is water. And base, water is a base because it is accepting H plus ions from acid and becoming H3O plus. So for base, we will get conjugate acid, and for acid, you will get conjugate base. So this Cl minus is called conjugate base and HCl is called acid. So HSO4 minus plus ammonia also NH4 plus and SO4 2 minus. So like this, you are going to get conjugate acid base pair differ only by one proton. Conjugate acid base pair differ only by one proton. Very important point. So the conjugate acid base pair differs only by one proton. So according to Bronsted law concept, an acid is a substance which is called proton donor and a base is substance which is called proton acceptor. Acid will give its conjugate base and base will give its conjugate acid. Continuation. Very important point. Please note down. A strong acid will have weak conjugate base and vice versa. And a weak acid will have strong conjugate base. And reaction will always proceed from strong acid to weak acid or from strong base to weak base only. For example, HCl is strong acid and its conjugate base is, what is conjugate base of HCl acid? Cl minus. It's a weak base. Similarly, water. Water is a weak base and its conjugate acid H3O plus is strong acid. So you should think for strong acid, you have a weak conjugate base. And for a weak base, you have strong conjugate acid. Weak conjugate base. Here I'll write conjugate base. And here also I'll write conjugate acid. Strong conjugate acid. So it's very important. Strong acid will have weak conjugate base and vice versa means strong acid. What is a weak conjugate base? What is its weak conjugate base? Because HCl is strong acid already we know. So Cl minus should be conjugate weak base. Similarly, water is weak base and H2O plus is strong conjugate acid. This is very important point. Please note down. Reactions will proceed from strong acid to weak acid or from strong base to weak base. Continuation now. So HCl is strong acid, its conjugate base is Cl minus. Base is ammonia, its conjugate acid is ammonia is a strong base, so its conjugate acid is NH4 plus. H2SO4 is strong acid, so conjugate base is HS4 minus. Simply what we are doing by subtract, how we are getting this? Simply by subtracting H plus ions minus H plus minus H plus. If you do minus H plus, automatically you'll get minus here. Since proton is going off, so you'll get Cl minus. Similarly for this, what you are getting plus H plus and also plus H plus by adding H plus ions. So this is weak base, strong conjugate acid. Strong weak base, strong conjugate acid. Strong acid, weak conjugate base. Strong acid, weak conjugate base. Amphoteric or amphipotic. Substances which can act as acid as well as base are known as amphoteric or amphipotic. Example, HCl plus water gives us H3O plus and Cl minus. And ammonia on reaction with water, it forms NH4 plus and OH minus. So it is acid and it is base. So these are called amphipotic. Amphipotic or you can say amphoteric. Amphipotic or amphoteric. Very important. Next concept we have Lewis theory of acid-base in salts. Very, very important concept. Lewis concepts of acid-base in salts. Now we are going to discuss. So why Bronsted theory is also failed? Because he could classify many substances into acid and bases, but exact acid and what exact base he could not explain because carbon dioxide, sulfur dioxide example. I'll write here limitations of Bronsted concept. Limitations of Bronsted law concept. Please note down here in your classwork. Limitations of Bronsted law concept. Before going to Lewis concept, I'm writing here since there is no slides given. So he could not classify, he could not explain the acidic nature of carbon dioxide, comma, sulfur dioxide, etc., and the basic nature of calcium oxide, magnesium oxide, sodium oxide, etc. So that's why he could not explain the acidic nature of carbon dioxide, sulfur dioxide, even though they are acids, etc. And also the basic nature of calcium oxide, magnesium oxide, sodium oxide, etc. That's why his theory is failed. This is called limitations of Bronsted law concept. Limitations of Bronsted law concept. So please copy it in your classwork. And and to some extent, it is more successful than Ionic because he could classify many acids and bases and he could not explain the acidic nature of carbon dioxide, sulfur dioxide, etc., and the basic nature of calcium oxide, magnesium oxide, sodium oxide, etc. Since already we know non-metallic oxides are acidic in nature and metallic oxides are basic in nature. So please note down this sentence in your classwork. So this is the limitations of Bronsted law concept. And important is what is conjugate acid base pair theory is very, very important. Next, we are going to discuss Lewis concepts that is also called as electronic concept. Very, very important from Bronsted concept and Lewis concept, definitely you'll going to get questions, which we are going to discuss anyway in the end of this session. So Lewis concept. Next concept is Lewis concept. Very, very important. An acid is any molecular ion which can accept an electron pair with the formation of coordinate covalent bond. Coordinate covalent bond. This is coordinate covalent bond. So an acid or any molecule is any molecule which can accept an electron pair. So if a substance is ready to accept electron pair with the formation of coordinate covalent bond, it is called as acid. So acid is nothing but electron pair acceptor. Acid is nothing but what? Electron pair acceptor. And base examples, all electron deficient molecules. What it is, why it is called electron deficient? Because since if you see BF3, boron trifluoride is electron deficient. Why? Because you know boron has how many electrons in the valence shell? 3 electrons in the valence shell. And these 3 electrons will shared by 3 fluorine atoms. So after formation of compound, they have only 6 electrons shared. So total 6 electrons. But according to octet rule, a substance should form octet, means it should contain 8 electrons. That's why it is called electron deficient molecules. Once again, I repeat what is electron deficient molecule. It is happens in the case of boron trifluoride as well as aluminum chloride. Why they are called as electron deficient? Because boron has 3 electrons in the valence shell and it shares 3 electrons with 3 fluorine atoms, and on the whole it shares it totally it becomes 6 electrons after forming compound, and after the formation of compound according to octet rule it should have 8 electrons. Then we can say they are called electron precise compounds, and since 2 electrons are deficient, so that's why they are called as electron deficient molecules. And these electron deficient molecules are readily accepting electron pairs. As they are electron deficient molecules, they can readily accept electron pair, so that's why they are called as Lewis acids, very, very important. What are Lewis acids? Electron acceptors. In simple words, Lewis acids are called as electron acceptors. And electron deficient molecules such as boron trifluoride, AlCl3, etc. Cations like H plus. H plus ions, if they want to become neutral, what it has to do? It has to accept an electron pair, then it becomes hydrogen. So similarly, Fe plus 2. So all cations are called as Lewis acids. Molecules with vacant orbitals, SF4 and PF3. SF4 means it contains lone pair of electrons because you can see here, sulfur has how many valence electrons? 6 valence electrons. 1, 2, 3, 4. 6 electrons. So with the 4 fluorines, they combine SF4. So it has one lone pairs. Lone pairs means it has one lone pair. So molecules with vacant orbitals, SF4 and PF3, are said to be Lewis acids. Very, very important. So these are called Lewis acids. So please note it down. An acid is any molecule or ion which can accept an electron pair. If a substance is readily accepting an electron pair, we'll call it as an acid, that is called Lewis acid, with the formation of coordinate covalent bond. For example, if you see boron, what happens? Ammonia is a Lewis base. Ammonia contains one lone pair of electrons, so it donates its lone pair of electrons to BF3 and it forms ammonia boron trifluoride. So it forms what? NH3, 2 electrons, BF3, ammonia boron trifluoride. This type of bonding is called as ammonia is donor, BF3 is acceptor. So this is called a coordinate covalent bond, which you already discussed in chemical bonding. So due to the formation of coordinate covalent bond, so that's why here, BF3 is accepting electron pairs, so that's why it is called Lewis acid. And ammonia is donating electron pair, and that's why it is called Lewis pair, Lewis base. So, according to Lewis acid, what is a Lewis acid? Electron pair acceptor. So, what are electron pair acceptors? Examples: electron deficient molecules, cations, molecules with vacant orbitals are said to be Lewis acids. So, please note down. Continuation: what is a Lewis base? A base is any molecule or ion which has lone pair of electrons which can be donated. So base electron pair donor. Molecules with lone pairs ligands are called as Lewis bases. Example ammonia. Ammonia contains how many lone pairs? One lone pair. Phosphine contains one lone pair. Water contains two lone pairs. So water is a base. And methanol is containing methanol. It is called methyl alcohol. It is called as methanol. It also contains one electron pair. So molecules with lone pairs or ligands are called as Lewis bases because they have one lone pair of electrons which are ready to donate lone pair of electrons. These are ready to donate lone pair of electrons. Lone pair of electrons. So that's why they are called as Lewis bases. So base is nothing but electron pair donor. So it is as simple as that. So a substance which has lone pair of electrons are called as Lewis bases, and a substance which has capacity to accept lone pair of electrons are called as Lewis acids. So Lewis acids, Lewis bases definition is clear, very, very important. So let us continue now. Now let us see for which of the following reactions identify the Lewis acid and Lewis bases. Very, very important. So here AlCl3 plus Cl minus gives rise to AlCl4. Since AlCl3, I'm writing here, just wait. AlCl3 is electron deficient, so it is Lewis acid, and Cl minus contains lone pair of electrons. Cl minus donating its lone pair of electrons to AlCl3, so it is called Lewis base. Simple it is. Similarly, ammonia, it contains lone pair of electrons, so it is Lewis acid. Ammonia is Lewis acid, and silver plus because it is a cation, so silver plus is Lewis base. Sorry, ammonia is Lewis base, and silver plus is Lewis acid because silver plus can accept electron pairs from ammonia since it contains one electron. So ammonia is Lewis base. Again, we're writing clear. Please note it down. Ammonia is Lewis base. Silver plus is Lewis acid. Sulfur dioxide and OH minus HSO3. So sulfur dioxide contains lone pair of electrons and OH minus, since sulfur dioxide is vacant orbital. Sulfur dioxide is vacant orbital. So it is called Lewis acid, sulfur dioxide and OH minus. So sulfur dioxide is Lewis acid and OH minus is Lewis base. Similarly, Cr plus 3, 6H2O. Cr plus 3 means chromium plus 3, positive ion. So it is Lewis acid, and H2O is Lewis base because it is only ready to donate lone pair of electrons. Here again, ammonia, simple. Ammonia, Lewis base, and BCH3 boron trimethyl group. BCH3 taken thrice is Lewis acid. So this is about Lewis theory of acid and bases. So which of the following is Lewis acid, which of the following is Lewis base? That type of questions are important for entrance. That's why I have made 5 questions here. So these are the answers for these 5 questions. Please note it down in your classwork. So electron deficient compounds, electron deficient. Here, this since it is electron deficient, that's why since it is containing vacant orbital, that's why it is called Lewis acid. And since it contains metallic ions, positive ions, that's why Lewis acid. So Lewis acid, electron deficient molecules, vacant orbital molecules, and positive ions. Lewis base is simple electron donors. So which contains lone pair of electrons. Ammonia contains lone pair of electrons, and that's why it is Lewis base. OH minus contains lone pair of electrons, so that's why it is Lewis base. H2O contains OH lone pair of electrons, 2 lone pair of electrons, that's why it is also Lewis base. And Cl minus also contains lone pair of electrons. That's why it is also called as Lewis base. So Lewis bases means which contains lone pair of electrons. Lewis acids means which accepts lone pair of electron. So what are the categories under Lewis acids? Electron deficient compounds, vacant orbital compounds, or you can say non-metallic oxides. Non-metallic oxides are also called as Lewis acids. Simple words. Vacant orbitals also nothing but vacant orbitals are non-metallic oxides, and metallic ions, cations. Cations means positive ions. So cations, electron deficient molecules, and non-metallic oxides are Lewis acids. Are Lewis acids. So note down. So please note down in your classbook the answers. Let us discuss now. Continuation now. So more about the questions based on conjugate acid base theory and Lewis theory we'll discuss in the next session. So in this session we have discussed all the 3 theories of acid and bases. So next theory we are discussing more about acid base and salts. That is questions based on acid base and salts. So I'm stopping this class. Thank you.